Okay, we are in a discussion of AWS Solutions Architect, and today we're going to discuss another topic, Kubernetes, right? So, my previous videos, we have been discussing about Elastic Container Service, which is ECS provided by AWS. And in that video, I told that I'm going to discuss Kubernetes in next video because they all related to containerization, right? And today we're going to discuss Kubernetes in going to understand how they works, right? Okay, as I discussed in my previous video, a similar way I'm going to take an real life example for comparing the Kubernetes, right? How they work. So it's easy to understand. So here, got a smart apartment building, modern apartment building. You probably have seen high-rise buildings. They are in every cities today, right? So in a ground floor, you have so many controls installed in the ground floor, right? You go parking, you have control rooms, right? Electrical control room, and then yeah, conditioning control room. So many things in the ground floor, right? Infrastructure is the servicing the whole apartment building, right? And then you have each floor has a separate apartments, right? Apartment units. So people buy them and live in there, right? So in here, it is we comparing Kubernetes architecture in a smart apartment building cross section, right? So you could see this apartment building the units, pods and containers, and then you can have a Kubernetes, so controls, and then you have a scheduler, right? And then in the bottom you can see control panel and infrastructure. So let's have a look how we just compare and how do you compare each unities in this apartment building to Kubernetes architecture, right? So the building contains a building manager, right? Building manager is the control panel. So that is where you control whole building infrastructure, all the services you control from a control panel in the bottom of the building, right? And then you got a floors. Floors are worker nodes like floors. You have apartment units, right? So in that apartment units, so people buy them, and that their nodes, right, become their apartment, and then pods. Pods are the apartment containers, right? And then tenants, like the people who is going into that units, going to be like containers, right? So, so that is the building components, and then building service. So building services. So security desk is the application programming interface server in here. It's comparing the application. So the maintenance is staff is a Kubernetes. So how do you maintain the building, right? Looking after building maintenance, right? Then elevator system is a scheduler. So which time you go up and down, how do you do, right? And then utilities, you have networking and storage under utilities, right? Okay, so the pod container living arrangement, right? So most common single tenant apartment. So single tenant means that let's say it's a one family living, right? So it's belong to one family. So one tenant is a container per apartment. apartment is like pods. You can see it can be a one tenant, right? One tenant is a one per pod, right? So that is the example. So web server pod, one Nginx container serving web traffic. So it's a one, right? So advanced patterns, roommate apartment. So it's just like a shared accommodation, right? So multiple tenants, right? Containers sharing one apartment pod. So it's like one apartment sharing with the multiple tenants. Like let's say something like take into a this apartment is closer to one of the university in the city, right? Let's say one of the few university students hire uh, these one of these uh, apartment, right? In a one pod. Then they share all their rent, and let's say rent is $500. So let's say four people, four students together. So one of them pays $125 and sharing, right? And then roommate share utilities, the kitchen, bathroom, internet. You know, internet is like a network storage volume, sort of like roommate share kitchen, bathroom, and internet. Let's say you have a one uh, fridge, refrigeration unit, right? And four of them, they keep their foods and everything, but it's in a one unit, but it's a shared, right? So example, so web server plus login sidecar pod, right? Nginx and log collector containers. So there are few different things running inside the same one as a sharing together, right? So how this smart building works? The building manager, the control panel oversees everything. So control panel oversees everything. So everything is there. So who living is controlling all these facilities in there, like the electricity, air conditioning, everything is in there, right? And then while maintenance staff collaborate to ensure it will run smoothly. So make sure maintenance staff make sure they everything works smoothly. Let's say you don't have power to one of the floor, then a maintenance staff go there and fix the problem. Okay, so something like that. And when a new tenant, right, need housing, right, the elevator system finds the best available apartment on any floor, right? So when a new tenant comes, they find out, all right, so we have to get another, like when you get a more demand, right? You get one of the other unit will be applied. That means, okay, so which apartment the new tenant should be putting in. So it's right, and then someone's leaving, so it's become evacuated, and then it's going to use another busy period or something like that, right? Um, Key insight: the shared resources, right? Containers in same pod share resources, just like roommate share apartment utilities, right? So network, the same IP address, like that pod, use the same IP address, the same pod, right? And then storage, shared volume, like sharing a refrigerator. I said like you keep your food and someone else keep their food. So refrigerator is shared. The life cycle move in out together. So pod creation and deletion. So once they finish their university or first year or something, maybe they will get accommodation in the university accommodation. Once you get a university accommodation, people move after 1 year and they go into a different uh, apartment altogether, right? So this pod creation and deletion is an example. This is why container in a different pods cannot directly share these resources. They are in a separate department. So separate departments So they can't share something in a different department, right? It's the same department, they can share the details, right? Whatever their facilities, resources inside. So it's a bunch of them in one pod. It's going to be same IP address, shared volumes, something like that, right? All right. So the smart building, the real Kubernetes architecture, so building analogy. So again, if we're looking into that a little further, so building manager controls everything, and the floors, the physical infrastructure, apartments are the logical units, and tenants individual occupant, right? So Kubernetes reality is control panel is the API server, scheduler, and ECTD, like whatever controlling. The worker nodes is a Kubernetes Kube proxy, and then pods, shared namespaces, volumes, containers are the application process, right? So pod definition example, right? API version, name apartment pod, all right? Spec containers, right? And Kubernetes control commands, right? Uh, get pods list department, right? Control describe node, right? Inspect flow, like that, right? So smart building to Kubernetes architecture mapping, right? Again, you could see the same thing, right? See, that's a building manager, manage everything under this is, let's say, ground floor is a control panel, scheduler, API server, ETD, everything is there. And then you have uh, flows, right? Worker nodes, right? And then here, the flows, right? See, this is the flows, right? Management layer, and then infrastructure layer, right? And then you have application layer, department pods, right? So that is how it's comparing with the actual world examples, right? Okay, so when we talk about the Kubernetes, so I just thought to give you an idea of the what are the things we can do with Kubernetes. So this is one of the options, CI/CD pipeline, the complete guide, right? So what is this? We're going to talk about CI/CD pipelines. It's a Kubernetes related, right? So definitions and overviews, the continuous integration. That's what we call CI. The automated process of integrating code changes frequently to shared repository, right? So as you see, so Git up when you create an account and when you control your coding from there, right? And then you do continuous development with the different versions and everything. So that is we call continuous integration, right? Automated process of integrating the code changes frequently into shared repository, right? And then a continuous deployment, CD, automated deployment of the tested code production environment. So when it's after testing environment, development environment, and then they are ready. So CD means continuous deployment. So to deploy once it's ready to a production environment, that is called CI and CD. This is a sort of a continuous process, right? And so so these ones key component like Git repositories, right? GitHub repositories that's use coding and build animation, compile and package, and the testing, unit integration, E2E test, and then deployment, staging, and production release. So that's key benefits in this process is a fast delivery, reduce time to market, and then reduce risk, early bug detection because you do staging and then after production, so improved quality, So automated testing and then better collaboration, so team visibility, right? So you probably have used, so you probably have heard about seen some of the popular tools for this process, Jenkins, open source automation server, and then GitLab CI, integrated DevOps platform, and then AWS code pipeline. We're probably going to talk about that and cloud native solution, and then a GitHub action, so repository based workflows. So just to give you an idea, so CI/CD pipeline flow. So code commit, developer push, and then a build and compile package, right? And then to automate testing, and then deploy and staging environment, and then this is the production ready, right? And the developer feedback and code reviews and fixes, and then test result decision point, right? Testing pass, and then go there. So the best practice is frequent commits. So small atomic changes, small changes using the CI/CD pipeline flow, right? And then you testing it, right? And then getting a feedback, right? And then you have uh, quick recovery mechanism. So here the containers and Kubernetes integration. So containerization, Docker image built in CI pipelines, and their registry push. Images is stored in container registries. So we have to talk about ECR, Elastic Container Registry, and then KH developments, Helm charts, and Kube control manifest, right? Then rolling updates, zero downtime development. So this is the process of inside how do we to go with the Kubernetes, right? All right. So scalability and use cases. So we get to talk about a little bit of Kubernetes scalability and use cases. Flexible scaling support application from a small website to large enterprise applications, right? As like in ECS, auto scaling, right? Cluster auto scaler and horizontal pod auto scaler. So, like what we discussed, tenants coming and goes, right? So new tenants coming, like it can scale automatically, right? Um, Enterprise user cases, so microservices architecture and CI/CD pipelines. We discussed about CI, continuous integration and continuous development, right? Sorry, continuous deployment, right? The continuous integration, right? Continuous integration and continuous deployment. So CD pipeline that we discussed. So the machine learning workloads, batch processing jobs, powerful tool for secure and efficient Kubernetes management in a cloud native environment. And so when we see in Kubernetes so advanced capabilities, you have a dashboard, right? Monitoring an operation, then pod identity, simplified IAM credentials management for pods without a service account, then the EKS Anywhere, extend years edge computing in a hybrid cloud environment, right? EC2, worker node infrastructure, S3, the persistent storage for backup, Route 53, service discovery, fine-grained access control IAM, right? So AWS Solutions Architect key point in here, so fully managed Kubernetes service, no need to install, operate, or maintain Kubernetes control plane. So architecture components, so Kubernetes API server control plane, and then worker nodes. Current version support is 1.33, and global availability. It's available in any AWS region with the multi availability zone deployment, so high availability. For exam focus understanding manage self-manage Kubernetes deployment. right? So core features, orchestration, as we said, the managing these pods and controlling everything, right? Enhanced security, the encryption at rest and in transit are back. IAM uh, uh, authentication and authorization and VPC network isolation. So they work with load balancers, application load balancers, and then network load balancers, different traffic, and classical load balancers for legacy applications, right? So also the monitoring, logs monitoring will go to a cloud which containers inside for performance matrix, right? And then you can see EKS overview, so fully managed Kubernetes service on AWS, right? And then a control plane management, right? And then simplified operation, and then enterprise grade reliability, right?